In this problem, we're going to find the inverse, and then we're going to verify it. So I'm going to follow the steps to find the inverse. Now, first of all, here's my function f of x, and you'll notice that I have a domain exclusion of x cannot be equal to -1, because otherwise that would make my denominator 0. So the steps I take to find the inverse is first I change f of x into y. So y is equal to 2x minus 1 divided by x plus 1. I'm just changing f of x to y. Now, to make an inverse, my inverse makes my y's x's and my x's y's. So all I'm going to do is I'm going to switch the letters. I'm going to say x is equal to 2y minus 1 divided by y plus 1. This is what's known as the implicit form of the inverse. Just switching the x's and the y's is the implicit form. But what I want is the explicit form, which will take the form of y equals something. So what I'm going to do now is I'm going to take this equation and I'm going to solve it for y. So I'm going to start by multiplying both sides of my equation by my denominator here to get rid of my denominator. And so on the left-hand side, I'm going to have x times, x times y plus 1. And this is going to cancel out my denominator there. That's going to be equal to 2y minus 1. A little bit of tricky algebra here, so be careful. You'll do this a couple of times and then you'll be able to see it every time. I'm going to distribute my x. So I'm going to have xy plus x is equal to 2y minus 1. Now I want to get into something that looks like y equals. So I want to bring all my y's onto one side of the equation. So what I will do is I will subtract 2y from this side, and I'll subtract 2y from this side. So now I'm going to have negative 2y plus xy plus x is equal to -1. Well, I think what I'm going to do now is I'm going to just isolate again. I'm going to isolate my y's on one side of the equation. So I'm going to subtract x from both sides. So I'm going to have negative 2y plus xy is equal to -1 minus x. What I'm going to do now is I'm going to factor a y from the left side of my equation. So it's going to be y times -2 plus x is equal to -1 minus x. And you can kind of see where I'm taking this right now. I'm going to divide both sides by -2 plus x. -2 plus x. And what I'm left with is y equals -1 minus x over -2 plus x. And to write it as an inverse, this is an important step. I'm going to write f minus 1 of x is equal to -1 minus x over -2 plus x. This is the explicit form of the inverse. This is a perfectly good answer. There is nothing wrong with this answer, except that if for aesthetic purposes you don't like all these negative signs, I could take this right here and multiply it by -1 divided by -1. So this is equal to 1. I'm just multiplying the right side of my equation by 1. I don't have to do anything to the left side of my equation. But by multiplying the right side of my equation by -1, it's going to equal 1 plus x over 2 minus x. And I don't know, it's just a little bit more elegant looking. You do not have to do this. It's just something that it's a little bit easier to work with than having all those negative signs. Now, one thing to notice here is that in my inverse, x cannot be equal to 2. If x is equal to 2, I will have a 0 in my denominator. Cannot have a 0 in the denominator. So I have to notice that domain restriction. And now, I'm going to take my original function, which I can get right here in just a second, which is this. And I'm going to verify that, in fact, this is the inverse. And I'm going to do that by finding out if f of f minus 1 of x is equal to x. So let's do that. I'm going to take my f minus 1 of x, this whole term right here, and every time I see x in f of x, I'm going to plug it in. Let's make sure I can do that. So I will have need a little more room. I'll write room. I have 2 times 1 plus 2 times 1 plus x, 1 plus x, divided by 2 minus x, minus 1, divided by 1 plus x over 2 minus x plus 1. If I work that out and it equals x, so I'm going to put here, does that equal question mark x? If it does, then I have an inverse. So let's try and work this algebra pretty carefully. So in my numerator first, I'm going to do my numerator first. I'm going to multiply, well, this is 2 over 1, so I'm going to multiply the 2 times this term right here. So that would give me 2 plus 2x over 2 minus x minus 1. There's my minus 1 right there. And that is divided by my 1 plus x over 2 minus x plus 1. Now I'm going to do something to both my numerator and my denominator. I want to get a common denominator in my numerator. So I'm going to take my 1, and I'm going to change this. It's going to be 2 plus 2x over 2x over 2 minus x minus 2 minus x over 2 minus x. I've just changed my 1 into 2 minus x over 2 minus x so that I can have a common denominator. And I'm going to do a similar thing in my denominator. I'm going to have 1 plus x over 2 minus x plus 2 minus x over 2 minus x. Again, I've just changed my 1, so I'm trying to get a common denominator here. So now I have a larger fraction, 2 plus 2x minus 2 plus x over 2 minus x. That's my numerator. And my denominator is 1 plus x plus 2 minus x, again, over 2 minus x. Now, just to call your attention here, I did take this negative sign, and that became my negative 2. And the negative sign over here on this negative x is why it became a positive x. Excuse me. So let's simplify a little bit more. I'll look at my numerator. I have positive 2 and negative 2. Those go away. And I have 2x plus x. So I have 3x over 2 minus x in my numerator. And in my denominator, I have 1 plus 2, which is 3, and my positive x and my negative x cancel out, over 2 minus x. Well, now let's try and get rid of my denominator here. And I'm going to multiply this by its reciprocal, 2 minus x over 3. And if I do it on the bottom, I have to do 2 minus x over 3 on the top. So my denominator goes away. And I have 6x minus 3x squared oh, no, that was stupid. Why did I do that? Here I am making my life so much more difficult. I don't need to make my life that much more difficult. Let's erase this here. I got rid of my denominator. I can get rid of my 2 minus x's. I can cancel those out. That's a lot easier. And I have 3x divided by 3. My 3's cancel out. And in fact, I have confirmed that these are inverse because I have x. A lot of algebra in there that requires a little bit of thinking and a lot of care, but nothing that you are incapable of. You are all capable of doing this problem.